So now that we know scale drawings, I'm going to give you a preview of something that you'll see in high school geometry called dilations. In high school geometry, you learn about a bunch of different transformations or changes that you can make to a graph or figure. You'll learn things such as reflections, rotations, and translations. Now, the one that changes the overall size of a shape, aka making it bigger or smaller, is called a dilation. And you can see an example here where these triangles, one is significantly bigger than the other. You may be familiar with the word dilations if you've ever been to the eye doctor, the optometrist, and you have to get your pupils dilated, and that's what's in this picture. So dilating your pupils are when they get bigger. So if you think about that, the same is true for a graph. Dilating can either get bigger, like your pupils, or smaller. So before, when we were creating scale drawings, we really focused on those side lengths and multiplying those by the given scale factor. So here are two examples that you've seen before. If we're trying to recreate this rectangle here using a scale factor of 2, we really looked at the side lengths of those rectangles. So you can see like we counted this side length and multiplied it by 2 to get the new side length of 4. Even in dilations, we still call when something is getting bigger, like this, an enlargement. And similarly, if something is getting smaller, we still call that a reduction, even in dilations and not just scale drawings. So same math was true when we had a smaller scale factor. We still took the original side length here and multiplied it by that scale factor to get the new units. What's really going to change with dilation is the idea that we're using side lengths, and you'll see how that changes here next. So dilations, instead of focusing on side lengths, really focus on the coordinates of each point. And hopefully that word sounds familiar. Coordinates are the x and y locations of each point on the graph. And they are listed as where they are at on the x-axis and where they are on the y-axis, or just x, comma, y. So you can see I have my graph labeled here with the x-axis being that horizontal going left and right, and your y-axis being the vertical or how much it's moving up or down. Let's focus here on the x-axis for each point. If we look at A, I can see that's 4 over, so its x value would be 4. By comparison, B is on the left-hand side, and you can see that these are now negative numbers. So I would look at where B is, and that is over right here. So in between -6 and -8 would be -7. C is also to the left in between -4 and -6, so that would be a -5. And then D is all the way over on the right at 10, so its x value would be 10. So each of those numbers written in blue are the x values or the x coordinates, and you can see that's how much it's moved left or right. Now if I focus on the y values, that's up and down. So if we look at A, it's up in between 4 and 6, which would be 5. So A's point is 4, 5. So 4 to the right and 5 up. B is all the way up here at 8. So its coordinates are -7, 8. That -7 tells me to do left, and then the +8 is what tells me to move up. So then if we look at C, it is down here at -6. So a coordinate of -5, -6 tells me to move left 5 and then also down 6 since they're both negative. D would be down at -4, so its coordinates of 10, -4 tell me to move right 10 and then down 4. So to create a dilation, instead of multiplying the side lengths, we're actually going to multiply these coordinates by the scale factor instead. So let's look at two examples of that. So I mentioned earlier that we still call them enlargements and reductions, so we're going to look at one example of each of those. So an enlargement, or also called a stretch, is where the scale drawing will be getting bigger, or the dilated image will be bigger than the original. So it says dilate with respect to the origin. That just means we're going from the center, and that's what allows us to multiply the coordinates by a scale factor of 2. List the pre-image and image points. So pre-image is the original, kind of what you are starting with. So it actually wants us to label those points first. So if I look at A, it's 1 to the left and 3 up. So that would be -1 for the left and then a +3. If we look at point B, that is over 3 and up 1. So 3, 1. Remember that x goes first. C is to the left 3 and down 1, so that would be a -3 and a -1. And then D is actually not moved left or right at all, so we call that 0, and then down 1, so 0, -1. So just like before, we are still going to multiply. It's just the difference is instead of multiplying the side lengths, we're going to multiply each x and y by that scale factor of 2. So what that looks like is I'm going to do -1 times 2, which would give me -2, and then 3 times 2, which would give me 6. That would then give me 6 and 2, again, each piece multiplying by 2, -6 and -2, and then 0, -2. So now I'm going to graph those. So -2, 6 would be to the left 2 and up 6. And we call that, if you notice, we call that A prime with that little dash next to it. B would be all the way over 6 and then up 2, and again we would call that B prime. C prime would be left 6 and down 2, C prime. And then D prime would be 0, so not moving left or right at all, and then down 2, D prime. And you'd want to connect those just like they are in the original shape. So you can see the overall shape and size still is the same, it's just the size has doubled to 2 times as big. So main difference is focusing here on these coordinates and not so much those side lengths. Let's look at another example where it's getting smaller. So a reduction or shrink, this time dilate with respect to the origin by a scale factor of 1/2. So we can see very, very similar to scale drawings in the fact that over 1 is an enlargement, less than 1 is a reduction. So since that is a fraction like 1/2 that's smaller than 1, I can already expect my image or the after scale drawing to get smaller. So let's start just by labeling our coordinates for the pre-image, and remember that's the original. So A is not moved left or right at all, so I know that x value is 0, and then it's all the way up at 1, 2, 3, 4, 5, 6, 7, 8. So 0, 8 would be its coordinates. B is to the right, 1, 2, 3, 4, 5, 6, and then down 2. So a +6, but a -2. C is to the left, so 1, 2, 3, 4, and it would be negative since I'm moving to the left, and then up 2, so a +2 there. So I'm going to take each of those and multiply them by my scale factor of 1/2. So A would become 0, 4. B prime would become 3, -1. And C prime would become -2 and 1. So let's look at where that would be. A prime would not be moved left or right at all, but just going up 4. B prime would be over 3 and down 1. And then C prime would be to the left 2, but up 1. And you'll notice that I labeled my points as I went. That's going to be very important for you. So there is my new triangle or my new image, A prime, B prime, and C prime. And you can see with that scale factor of 1/2, my second image is smaller than the original or the pre-image.